Hello. Again, my name is Teren Sapp. I'm SE Manager at Arista Networks. My territory I cover is pretty much, if you look at central U.S., pretty much the north half is all my area. So today we're going to talk about just a few different tools for automation, but then to get things going, we'll first talk a little bit about just failed automation in real life. So just a couple of industry terms that I got to learn myself. More from the aviation side was turnaround time. So turnaround time is basically the time that if you think about when a plane actually comes into a gate, how long it takes to get the people off, get the bags off, and then get the new people on, and then the new bags back onto that plane, and then actually getting that plane to actually take off and off the ground. So that's turnaround time. One of the key things about turnaround time that I actually got to learn is it's not just something that's competitive for the actual airline, but it's also something that's attractive for the actual airports. And it's basically a benchmark that the airports use against each other to attract new airlines and whatnot. One of the key components with turnaround time is actually getting the baggage. So getting people on and off, that can sometimes take some time, but obviously with baggage, if you think about just why the airports ask you to get there an hour and a half or 2 hours, however long it is, one of the big reasons is that they can actually get your bag to the right place. So to fast forward, anybody from Denver? Hopefully not. I'm going to pick on your city for a little bit. And if you're laughing, you already know the story. So in 1990, Denver actually began rebuilding their airport, or building a new airport. And as part of this endeavor, they decided that why just build a new airport and put the same old baggage system in that we had? So they actually began looking at how can we actually make the baggage system better and get our turnaround time down to, say, 30 minutes. Because if we could get planes in and out within 30 minutes, more planes, more airlines, which means more revenue for the actual airport. So all around a great thing. So the Denver International Airport did what any company would do, and so they went out and said, who's the best person in the baggage system industry? And basically said, here's what we want to do. What do you think? That industry leader came back and said that it's not feasible. What you're trying to do will not work. So they scrapped the project. No, that wouldn't make for a good story, right? They actually hired them. So they actually said, this isn't going to work, but then they actually hired them to actually build the system. I already told you it's a failed automation, so you see where this is going. So one of the very interesting things about this is they ran into basically everything that could go wrong did go wrong, essentially. Even the lead engineer on the project actually passed away, who was the guy that was really pushing a lot of these new ideas. So literally everything that went wrong could go wrong. One of the key things here, too, though, is the scope was constantly changing. That's never happened to anybody, right? And so with the scope change, it was just crazy things. Like they were about to implement the whole system, and they looked at it and they said, oh, geez, we need to support skis and golf bags, that kind of stuff too. And so they basically had to bring all these new stakeholders in and redesign the system from the ground up. All in all, this was very interesting to me. They actually delayed the actual airport opening by 16 months, costing the city of Denver $1 million every single day. So it was a tremendous failure. Here's a screenshot of what it actually looks like from a deployment, just so you can actually see the complexity really involved here. One of the really unfortunate things, depending on how you look at it, was that when they actually got the system rolled out finally, it actually only served a fraction of what they really wanted to do. Single airline for only outbound luggage. So literally pretty much nothing. And then in 2005, they actually ripped out the entire system because that small portion of baggage delivery cost more than the entire rest of the operation for the baggage system at the airport, just using traditional methods. So the reason I put this cartoon up is, and really it's something to really think about just automation in general. Make sure that what you're doing is worth it. Because if it's all just going to be ripped out at the end of the day because they say, geez, you just automated the task that was actually really not a bad task to do, or you overcomplicated that task, then you're really negating the whole purpose. So how does this actually affect getting to the Git commit? That was there was actually ONA going on earlier this week out in San Francisco, and our marketing department actually stole this from me. I'll admit, but I'm no marketer, but that was a proud moment for me. So a few key things about just automation is make sure you do it the right way. Make sure you get the stakeholders involved, and above all things too, remember that greater agility does usually come at some kind of cost, whether that's getting your team trained up to speed. One of a real world example for me that literally just happened this week, on my team, we were working on redoing some documentation, and one of the engineers on the team said, "Why don't we move everything to Git?" And I was like, "Sounds great." And then all of a sudden I realized that 8 or so of us never used Git before. So, and like any good engineer, we waited until an hour before it was due before everyone's like, "So how do we do this?" But we did get through it, and overall we're in a better spot because of it now. But then also, the other thing to remember too is we're not just talking about technology here, we're also talking about cultural change as well. So, and that goes from the top up and the bottom down. Because one of the things to me personally that I always think about is the same person that's asking you to automate this task, do it faster, do it better, is the same person that'll come back to you and tell you, "Hey, why did the whole network go down when we pushed out a change last night?" Automation, good and bad. So how do we get to the Holy Grail? Before we jump into that, we'll talk about just one sliver of DevOps. I'm myself no expert in the DevOps side, but one of the things that I've been trying to attend more of the DevOps days, conferences, and whatnot. Last year at Minneapolis, there's one gentleman that got up on the stage, and to adapt it to the networking world, he kind of said, there's two types of people. People that have taken down the network, and people that are about to take down the network. And I totally believe in that. And a lot of what we're really talking about here is just removing silos, working together more, focus on what the greater good task is that we're actually trying to accomplish. So to jump more into the technological side, we're really going to be talking about three main things today. Git for our revision control and peer review and whatnot, Jenkins for CI/CD, and finally Ansible. So Git, as I just got to find out this week, it's not just for developers. There's lots of cool use cases that you can use it for. There's probably a lot of use cases you shouldn't use it for, but it's a great tool that we have at our disposal. And all these tools are open source, highly adaptable. Similar to SVN, who out here has used Git in some form of capacity? Yeah, pretty much everyone. So one of the neat things about Git too is you don't have to use GitHub. You can actually run it locally on if you're running a Mac. You can have it right at your fingertips there. So think of it more in that terms of your configuration and whatnot doesn't have to live in GitHub, so your security and compliance department would probably have a field day with that. So Jenkins. One of the cool things about Jenkins is, so we have tools like Git and we have tools like Ansible, which we'll talk about in a little bit. But Jenkins is really sitting there looking at everything to automatically push out, run your playbooks and whatnot, and really kind of handle the orchestration piece of the puzzle, and really work in any of the custom workflows that you may have in your organization. Another neat thing about Jenkins too, tons of different modules. There's pretty much modules out there for pretty much everything. So Ansible, as the title says, somebody's got to do the work. So what we're using Ansible for this is really actually going out and actually configuring the devices, running our playbooks and whatnot. It's all Python-based, so very easy to extend. Tons and tons of different modules out there. All the major vendors have, even the not-so-major vendors, have pre-written roles and whatnot. We'll take a look at a couple here shortly. But also works with JSON too. So a lot of the stuff that we've been talking about today. So playbook, what does an actual playbook look like? we really have a few things. Basically, who's actually running the playbook? So in this case, we've got a couple of leaf switches. Who's actually in that group, and then are there any group vars? Think of group vars essentially as common sets of configuration. Like in this example here, we have a set of VLANs that we want across all those leaf switches. And then finally some actual host vars, so things that are more specific to that individual device. Then the last thing here too is really just actually running through those tasks and applying it to the appropriate device. Another thing that I actually didn't really use in any of the demo that we'll see here in a little bit, but I did want to mention just the power of Jinja templates. Jinja's, really think about how much fun is it to actually log into a switch and configure every single 48 ports on that switch. Nobody likes doing that. With a few lines of code like that, we can simply just roll out a template to automatically do that. So another great tool at your disposal. All right, so now we're actually going to get more into the demo perspective, and full disclosure, I chickened out. Unlike the other guys, I did a pre-recorded demo through a video. I'm usually more about doing the live demos, but today I figured I might as well play it a little bit safer. So in what we'll be working with here is we basically have a file that contains the IP addresses of all of our leaf switches. Then down here, we'll actually have we'll actually be defining an actual playbook using a pre-written role. And over here, if you're interested in looking at finding more roles, go out to galaxy.ansible.com. Like I said, tons of pre-written roles out there to really accomplish a lot of the tasks that you're trying to do. Then finally going over to the group variables files that we were just talking about. This is where we actually put in that common configuration, such as our VLAN definitions. So initially, you've got a little bit of setup work to actually get this set up, but then when you actually think about this from a day 2 standpoint, we're really just going in there, adding in our new VLANs, and then just running the playbook again. So it gets simpler and simpler as you go. So from an actual Git perspective, this is really all we're talking about as far as actually doing the setup. Just initializing the actual repository, adding all the files, then committing a change. So the neat thing about this too is so inherent in Git, we also have to put in some form of a message. So we can actually describe the change that we're actually doing to the actual network. And then finally, basically just pushing that change out to the master. So that's all fine and dandy. That controls more of the Git perspective. But then when we actually look at Jenkins, so what we can do with Jenkins, we can actually bind that to a Git repository and basically have it constantly watching, polling that Git repository for any changes. And basically, as it detects a change, we can actually have it invoke an Ansible playbook. To actually do that, we set up a build trigger to basically just poll Git. By default, you could have this be at 2 a.m. every day or 2 a.m. on a Saturday, or you can have it just do it every minute and just let everyone run wild. We can also, then we actually add in our build step to actually run our Ansible playbook, and happy day. So now we'll get into my fancy demo here. So what we're doing here, this is more of a day 2 example. We're basically going in, editing that VLAN definition file. That's just full disclosure. We have one VLAN or 2 VLANs deployed there. Like my video paused. There we go. Restart it. I was going to say, I swear I know how to type. I will admit it took a few takes to get it right, though. So now we're actually going in, adding in our VLAN ID 2000, the ever popular production. And then you can't have a production VLAN without, anybody have a guess? Development. So we go ahead, change that file. Now we just need to tell Git, hey, I made a change to this group variable file, and commit our change, put a super descriptive comment in there, as if you couldn't tell it from the diff. because that's one of the great things about Git is we can actually do a diff between the last change and say 2 weeks ago, or really whatever commit we want to look at. Then if we turn our eyes over here to Jenkins, again, Jenkins sitting there pulling every minute. So it's basically going to be, every minute it's going to be checking to see if there's any new commits to our repository. And hopefully any second here we'll see a new job pop up. And again, like in this particular example, we have it polling every minute. You may or may not want to do that. That's really more about what's most convenient for you. And also from an approval perspective, which we'll talk about too, this is also where you would want to make sure that you have some form of control in there, so that way everyone's not just running wild. So now if we click on the console output, we'll scroll back up here so you can actually see the initial side where we're actually detecting the change from Git, or the new commit. And then we scroll through here, and this is our Ansible playbook that's essentially running through here. And so it's pushing out, and we can see here that we hit every single device, added the VLANs, and now we finished successfully. If we take a look over here, we have now we have our VLANs deployed on the actual switch. So let's just kind of sum this up real quick as to what we actually just did. So we added a VLAN to the actual to the actual file, committed that change using Git. Jenkins sitting there polling, watching for any commits, and Jenkins invoked Ansible, which then Ansible actually runs that playbook, and now our switch is actually configured all using Ansible. Go ahead, question. In this case, so I'm not terribly familiar with Ansible Tower. This was more just an example to really show you the three tools working together. Someone else might have a little bit. I'm actually the opposite of Jeremy. I'm a network engineer that's trying to learn more about the DevOps side. So one of the powerful things about Jenkins is there's actually a plugin called Pipeline. It used to be called Workflow, that has allows you lots of flexibility to actually customize the workflow. So you could add in approval processes, or say this change can only be pushed out at this particular time, or this could only be pushed out by a certain user. So you could handle a lot of that stuff just through the workflow, or even just your polling interval. Again, set it to, it's essentially a cron job. So set it so that it's only running Saturdays at 2 a.m. With that, I did want to give a special thanks out to Alex Feigenson. He's one of my colleagues down in Texas, Austin, Texas. But by all means, if you have any questions, feel free to reach out. Otherwise, we've got a little bit of time that we can take a few more questions too. If there's anything else going on. Don't worry. All right, well, thank you very much.